Statsproblems.com was used to create this tutorial, which can help us calculate a least squares regression line and the hypothesis test, but with less calculation than a complete analysis because the means, the sum of products and sums of squares are given. Let's begin by selecting one of the 25 example problems. The question appears in the blue box. Below are the inputs to a regression analysis. Number of score pairs, n, is 7. Mean of x, x bar, is 3, mean of y, y bar, is 11. Sum of products, SP, is 460. Sum of squares x, SSX, is 200. Sum of squares y, SSY, is 1214. Alpha is 0.05. What is the least squares regression line? What are the results of the hypothesis test of the regression analysis? Let's step through the solution by clicking on the Next Step button. In Step 1, we calculate the slope of the regression line, b. The slope of regression line, b, equals the sum of products, SP, divided by the sum of squares x, SSX. In this example, b equals 460 divided by 200, which works out to 2.3. In Step 2, we calculate the intercept of the regression line, a. The intercept of the regression line, a, equals the mean of y, y bar, minus the mean of x, x bar, times the slope of the regression line, b. In this example, a equals 11 minus 3 times 2.3, which works out to 11 minus 6.9, which works out to 4.1. In Step 3, we calculate the equation of the regression line, y equals bx plus a. The regression line is y equals the slope, b, times x, plus the intercept of the regression line, a. In this example, the regression line is y equals 2.3x plus 4.1. In Step 4, we calculate the sum of squares regression, SS regression. The sum of squares regression, SS regression, equals the slope of the regression line, b, times the sum of products, SP. In this example, SS regression equals 2.3 times 460, which works out to 1058. In Step 5, we calculate the sum of squares residual, SS residual. The sum of squares residual, SS residual, equals the sum of squares y, SSY, minus the sum of squares regression, SS regression. In this example, SS residual equals 1214 minus 1058, which works out to 156. In Step 6, we calculate the degrees of freedom. In a regression equation with x predicting y, degrees of freedom for the regression term are always 1. So df regression equals 1. For the residual term, the degrees of freedom are the number of score pairs minus 2. df residual equals the number of score pairs, n, minus 2. In this example, df residual equals 7 minus 2, which works out to 5. In Step 7, we calculate the mean square terms, ms residual and ms regression. The mean square regression, ms regression, is equal to the sum of squares regression, SS regression, divided by the degrees of freedom regression, df regression. In this example, ms regression equals 1058 divided by 1, which works out to 1058. The mean square residual, ms residual, is equal to the sum of squares residual, SS residual, divided by the degrees of freedom residual, df residual. In this example, ms residual equals 156 divided by 5, which works out to 31.2. In Step 8, we calculate the observed f value. The observed f value is equal to the mean square regression, ms regression, divided by the mean square residual, ms residual. In this example, f equals 1058 divided by 31.2, which works out to 33.91. In Step 9, we find the critical f value. We need alpha level and degrees of freedom to look up f critical value. The alpha level is 0.05. In the F table of critical values, the column of the table indicates the numerator of the F ratio, which is the regression degrees of freedom, df regression equals 1. The row of the table indicates the denominator of the F ratio, which is the residual degrees of freedom, df residual equals 5. Use interactive table 8 to find the critical F value. Using the alpha equals 0.05 table, with df numerator of 1 and df denominator of 5, we find the critical F value of 6.61. We close this window to return to the analysis, which shows that the critical value from the table for df regression equals 1 and df residual equals 5 is 6.61. In step 10, we test the hypothesis. The observed F value of 33.91 is greater than or equal to the critical F value of 6.61, so we reject the null hypothesis. In addition to the 25 example problems, we can work step by step through an unlimited number of new problems using the Generate button. The Edit Data button can help us create problems with customized input. Instructors can use this function to create problems with complete solutions to use on exams, in class, or for homework. For printed output, we can print the question. Or we can print the question with the complete solution. You can also work out the complete regression line analysis and hypothesis test with scores as input, but this problem solver takes a long time to work out with so many steps. The free website has statistical analyses in all of the most common areas in statistics. Statsproblems.com also has a mobile version so you can access the site from anywhere. For help with statistical concepts, helpmewithstats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. In addition, helpmewithstats.com gives you free access to a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share statsproblems.com and helpmewithstats.com with your friends and instructors.